Hello, my name is Kunal Rush. In this video, I am going to demonstrate System Software and Compiler Lab exercise number 6, a single pass assembler for SIC. So in this experiment, we need to simulate assembler for SIC. So in this experiment, I am simulating assembler using Java code. So here I have written the code for single pass assembler. So first of all, here I have my input text. So this is code where I have written the input text, and to include the input and to writing the output, we are giving 2-3 files. So here, as you can see here, input, I'm giving input here, and then I'm having a op tab here for opcode. And to do the file manipulations, I have included two Java classes, that is buffered reader and buffered writer. Then I have included file reader and file writer. So all these are for reading and writing Java files. So first of all, I have created operand op and symbol, two variables of data type hash table, which is under import java.util.hash table, which will generate our hash table. Then using buffered writer, I have created two more objects, br and wr. Then I have imported both objects, both files, using specifying their address. So here I have specified both of their address. Then I'm declaring two string variables, line and title, and I'm initializing title with null. Then again I'm initializing lc and start, two integer variables, initializing with 0. Then I'm using for loop until line is equal to br.readline. So until br means this is our object for what we have read from the file, that input file. So until there's line into the file, until it's not equal to null, our for loop will execute. So inside for loop, if line dot contains start, that means if input is having start, like here it's having. So if input is having start, we have to perform, we'll split all the words into array, and we'll store it into a string array called c, and then we'll initialize the first value with title. So title will initialize what we have declared here with the first value of the array. Then we have to check if c.length equal to 3. Until it's equal to 3, then initialize start equal to integer dot parseInt. So it will convert the array into integer and it will store into start, and then again it will be stored into lc. If it's not if the length is not equal to 3, then we'll just initialize start equal to 0 and lc is equal to start. Then we'll write our object for buffered writer will write as wr.write line plus new line. So we'll just add a new line. Else if line doesn't contain start, if we don't have start, that means if also it doesn't have end, that means it's not the starting line and the ending line, then we have to do else equal to, we have a predefined function called pass1 symbol update. Inside hash function table we have this function. Then we'll pass this 5 arguments, that is line, op, symbol, lc and wr, the objects. And then if we are having end, if we are having last line, we'll just do wr plus write, then integer dot to hex string. So it will convert to 2 hex string. Then we'll provide lc inside the argument, and then we'll give small space, then line, then new line. And then here, after the loop is finished, after the reading of the input is finished, we'll initialize length equal to lc minus start, and then lc is equal to start. Then we'll just close buffered reader and writer. Now we have closed buffered reader and writer. Then we'll create one more buffered reader instance for reading from the input file, and the input file we have is inter.txt. So inside inter.txt we'll be storing the assembled code, that is the output that we are getting after assembler. So again the same conditions we are providing inside, and if it is start, we'll just give, so this is header record h, and then we have delimiter sign, then title, then this format is for assembler, and we are providing under start. Then if it is end, we'll provide end record. So end, after that we'll just convert the hex string into integer. If it is not start, if it is not end, then we'll just write lc equal to pass2, which is a predefined function in hash table, and then line op, then provide all the symbols, and then we'll just close the buffered reader object. Then we are writing the predefined functions that we the functions that we defined before. So the function that we used before are to6, pass2, and pass1 symbol update, and here ready op table. So all this we have used in the above code. We'll just define it here. So to6 is from x to word length. I'll start and I'll do up to 6, then I'll increment x, then I'll just add word equal to 0 plus word. That means I'll just add 0 before word, and then I'll just return the word. Inside pass2, what we are doing, we are just first creating a string object, then we are doing test record, and then we are adding to6 integer up to LC, then we are again adding our symbol, and then we are adding 03, and then we have if op equal to contains key C2. If we are having the key inside our newly created object, then we'll just do this object code equal to object code plus this sign, and then we'll just add it to our pre-existing object code, and they will give system.out.print our object code that we have generated. Also, if we are having RESW, the reserved word, reserved byte, or word, we'll just do the following operations like we have done before. And next function is pass1 symbol update. So pass1 symbol update, we are just providing symbol to the symbol table, getting from the op table, providing symbol to the symbol table. So we'll just declare, we will have this 5 arguments inside our function, and then it throws IO exception. So I'll write IO exception, and then if OP contains C0, if we have match up to A to Z, then what we'll do, we'll just put it system.put object.put C1 0, and if we don't have it, then we'll say that label already exists. And again, if it is word or reserved word or reserved byte, we'll just write. So we'll use WR our writer buffered object, and then we'll write up to line, and then we'll use integer.to hex string LC, and then we'll do the same thing for these two. And our last function is ready op table. So what ready op table will do, it will just create buffered reader object from our op table. So what we have in the op table, it will create object for that. So here I am having op table here, so I am specifying STA op as 23 and LTA 00. It will create op table for that. Then I am creating line this is object for string, and then I am running loop up to we have input, same that we have done in before two functions. Then string s equal to line.split, I'll just split and store in the string array. Then I'll use this function op.put C0 of integer.parseInt first one, so it will put inside it, and then I'll close the object and they'll return OP. So this was the program for assembler. So let us first see the input. So this is the input for this is the input program that we are going to give inside the assembler, and this is the op table for the assembler. Now we'll run it and see the output. So this is the output assembled code. So as you can see, this is the head copy, the header record, then this is the name of the program, then we are having some text record, their addresses, and then we are having end record. So this generated output will be stored in our file inter.txt. So this is the generated output. So we are having, they are providing all the addresses here, and at the end they are providing the end address. So thank you for watching the video.